Okay, thank you for introduction. It's the last talk. I hope you're not very tired. Here's the question. Who is using PostgreSQL in production? Not bad. Okay, and who is using it along with ClickHouse in production? Okay, maybe that's talk for you. Oh, sorry. Okay, so who am I? Currently, I work as a database engineer for a company called Adjust. It's the mobile attribution company based in Berlin. Before, I used to work for Zalando, where I was building Postgres operator for Kubernetes. And before that, I used to work for Avito, which is the biggest classified in Russia. Okay, so what are the current ways of shipping data from Postgres to ClickHouse? First one, you can simply trigger copy command and output it to standard output and feed that to ClickHouse client, which is pretty straightforward. Maybe most of you did that. Another way is to use the ClickHouse foreign data wrapper. Some of them allow you to write to ClickHouse, some of them not. Another way is to use trigger-based solutions. So basically, you put triggers on the tables which you are willing to replicate and save the changes into the queue, for example, PGQ, which is fine, and then replay those changes on ClickHouse side. Basically, you consume the queue and then replay. Or you can use Kafka if you already have it in your system, because ClickHouse provides you engine to consume data from Kafka. Or you can use logical replication, which is kind of new feature starting from PostgreSQL 10. It basically allows you to replicate data from one PostgreSQL instance to another. By data, I mean separate tables, but we'll talk about that. But first, let's talk about replication in general, and to talk about that, we need to be familiar with two terms. First one is write-ahead log, which is basically basically contains the binary changes of your data files, which are tables, indexes, and anything else, whatever you store in your database. Another term is log sequence number, which is basically position in the whole segment, which is 64-bit integer. Okay, so basically replication can be of two types. I think it's common for most of the database. It's physical and logical. In case of physical replication, you get the binary copy of your whole instance, and you can only have read-only queries on your replica side. Or you can have logical replication starting from PostgreSQL 10. So you don't have to replicate the whole instance or the whole database. You can specify which tables to replicate. You can even specify which comments to replicate. Like, I want to replicate only inserts to my replica or only deletes or truncates, starting from PostgreSQL 11. In this case, we ship not binary changes, but we ship some kind of abstract changes. So they contain information about the tuples we modified or deleted, and they are replayed on the replica side. In this case, you can read and write to your replica. As you might notice, there is a new component on that schema compared to the previous one. When we had like just wall sender, we have a logical decoder. Basically, logical decoder transforms changes from wall segments into a specific format, which can be any. For instance, there are some output plugins which can produce JSON format, like as you can see on the slide. Or you can there's a built-in one which is called PG output, which is used by vanilla Postgres logical replication. Or you can even send your data in a protobuf format. Okay, so logical replication uses publisher-subscriber model. So basically, you can have a single publisher and multiple subscribers to that publisher. You can specify which DML comments you want to replicate. So like only inserts, updates, or all of them. And you can specify which tables, basically, you want to replicate. And in case of logical replication, data streamed only on transaction commit time. So if you have something long-running on your master and it's rollbacked, then replica will not see it, which is quite logical. OK, and the logical replication uses the internal output plugin, which is PG output. OK, so in order to specify which tables to replicate, we need to create a publication. And for example, we want to create a publication for all the tables, which will replicate only inserts. Also, we need to specify how we replicate the comments. In case of inserts, it's kind of straightforward. You just get what you received from the logical replication slot and insert it to the destination table. In case of truncates, it's also quite simple. But in case of updates and deletes, you need to somehow specify which rows to update. And to help that, there is a special property for the table called replica identity. It can be any of four values. First one, it's default. In this case, the columns of the primary key will be used to identify the column, the row. It can use a unique index if you don't have a primary key. In this case, unique index should cover only not nullable columns. So it's the explicit way to identify row as well. Or in the worst case scenario, you can use the whole row to identify all the values of the row to identify it. But it's from the performance perspective, is not very good because it leads to sequential scans, but it's out of the scope of this talk. Or you can specify nothing. In this case, if you update or delete rows from the table, it will raise an exception. So at this point, we know what we want to, which tables we want to replicate, which comments we want to replicate. We know how to identify the rows. And let's get back to the initial schema where we had master PostgreSQL and replica PostgreSQL, which is basically can be treated as master as well. And let's substitute replica PostgreSQL with ClickHouse. But ClickHouse doesn't know anything about logical replication protocol and format. In this case, we need to somehow help it. So we built a tool which consumes changes of the logical decoder, the built-in one, and inserts comments to the ClickHouse. So it's a simple tool written in Go. It creates initial copy of the table from PostgreSQL to ClickHouse, and it keeps the track of the changes. So in case you restart the tool, it will continue consuming changes from point where it stopped. It uses the vanilla Postgres starting from version 10 because it was the version where it was introduced. So you don't need to install any other plugins or extensions because it's using the built-in one. It can also use the internal buffer so that you won't get every insert replicated to ClickHouse, which ClickHouse doesn't like. So it accumulates the data and then flushes to the table or buffer table. Let's have a look at the simple config. So we want to replicate a table from pgbench tool, which is called pgbench accounts, and we want to replicate it to ClickHouse table called ch accounts. In this case, we are using collapsing merge tree, which requires sign column to be specified. So we need to say that sign column called sign, obviously. And we need to specify the credentials to connect to the both databases and some other parameters. So currently it supports 3 table engines. These are merge tree, replacing merge tree, and collapsing merge tree. In case of collapsing merge tree, as it was mentioned, we need sign column, and it requires full replica identity, because when you have full replica identity, you get the whole row of the old tuple when you update the table, when you update the row. In this case, we simply insert a new row to ClickHouse with a -1 in the sign column in order to discard the old value. And we insert the new value with sign +1. And in case of deletes, we only discard values. So what we have, simple example, we have a table with one row, and we want to update that and change the name from John to Richard. So we insert 2 new rows, one of them with -1 signed and another one with +1 signed. ClickHouse will optimize them in the background, and we don't need to worry about that. In case of replacing merge tree, we need to specify the version column. And we need to put something there. And here comes the LSN, the log sequence number, which is present in the output of the PG output plugin. So, for instance, we had the same table, and we simply insert the new value with the new version. OK, and in case of merge tree, only inserts are replicated, and deletes and updates, they are discarded because we don't know what to do with that. Basically, that's it. Thank you. Questions?
Did you measure the difference on performance between the options you proposed at the beginning?
Do you mean by comparing the tools?
Yeah, like with the copy, the...
OK, the problem with copy and the first one that you need to keep track of what data you shipped. And in this case, in case of a logical application, it's done seamlessly to the database. So basically, you don't...
Yeah, but you could do that, for example, with Kafka, I guess.
Yes, but that requires if you have a Kafka already in your system. But if you don't have, then why to introduce?
I just was to know the numbers if you have them, but...
I don't have any benchmarks so far. It's a pretty young project, and yeah, if you can benchmark it, that would be very nice.
Thanks.
I understand that it's open source project, right?
Yes, it's open sourced, and it's here, the first link, and the other links to read further about logical application and some other stuff.
Hello. One question. Have you tried to measure the difference between using the replacing merge tree and the collapsing merge tree in terms of performance?
I didn't do any performance benchmarks, and I guess the main topic here is to replicate the data. Like, so far, the performance is not that important. But that can be done. I mean, it's a pretty young project. I need to do more.
And also, you are relying on the background task of ClickHouse to optimize the table and so on. Otherwise, the changes that you introduce are not really performed, no?
Those background tasks, they are on the ClickHouse side, so I don't manually run any optimized queries, and I guess you shouldn't do that.
Thanks.
Okay, so Alexei told me about how you can query collapsing merge tree table engines. So basically, you can multiply by sign column. If, for instance, if you want to sum a balance or something, you just multiply it by sign column, and it will get the correct result. Okay, as for the replacement registry, it's kind of more complicated. You can use argmax, as Alex says. I mean, in both cases, you need to you need to modify your queries. That's the conclusion. I mean, nothing comes for free.
Did you try it, or do you think it will work with Redshift cluster?
I have no idea. I haven't touched Redshift, so no comments on that.
Okay, thank you.
Okay, they say it will work.
More questions?
Which would be the typical lag between Postgres and ClickHouse?
Can you repeat the question?
Which could be the typical lag between ClickHouse?
Lag?
Lag.
Okay,
Delay.
so the question, what will be the lag or between data in ClickHouse and the Postgres?
Yeah, the typical delay using your plugin for logical duties.
I would say that would be kind of short, and it depends on how fast ClickHouse inserts the data. So, but typically it's very fast.
In the order of seconds,
I
milliseconds?
can't say, as it's kind of a young project. It needs more benchmarking, and we at Adjust are planning to use it in some of our subsystems. Maybe later we will present another talk talking more about having more numbers.
Cool, thank you.
You mean time by timeout before it flashes? Okay, so the question was, what's this size of the batch, and what's the timeout before it flashes to the buffer or main table? You can specify it. It's first one, it's max buffer length, which is number of DML operations, and the timeout is inactivity flash timeout, which is right there.
Can you lose some changes, like, because you have two commits, so like you are reading the log and at some point you put it on ClickHouse, but the commit fails, and how you handle that kind of situation?
Okay, so you mean if it fails to flash to ClickHouse?
Yeah, or maybe repeated events. You can have both. Depends where you have the fails, either reading the log or either in commit.
I mean, for that case, the buffer table is introduced. So basically, it first accumulates data in memory and then flushes it into the buffer table. And after that, from the buffer table, it flushes that to the main table by doing insert select. And if something goes wrong, if, for instance, in the middle of this period the tool fails, it will restart and repeat. It will consume the data which hasn't been merged by storing LSN position in the state file, which is right there.
So you will have repeated events in that case, I guess.
That's a good question. I need to investigate it.
Hello. How was the process of like thinking what database you was going to need? Like, did you spend a lot of time thinking that you were going to apply ClickHouse, or you were measuring a lot of databases? I mean, how was the process before making the migration?
I think if I get your question right, we will still use Postgres as a main database because it's It's simply awesome. It's good for OLTP load, but application can decide if there's an analytic query, it can go to ClickHouse and query ClickHouse for kind of all-up load. So I think the answer to your question is we'll use both. We're not willing to migrate from one to another. It's kind of like using good things of the both databases.
Thanks.
Okay, I think that we are good to go. Thank you.
Thank you.
Hi, everybody. As I said before, my name is Robert, and I'm the CEO of Altinity. I was asked to say a couple words just to close things up, and the words are just one word: thanks. I'd like to thank, first of all and foremost, Javi. Where are you? Javi, stand up. Please, a big round of applause for Javi. I'd like to thank the Google campus for providing the venue. This auditorium is absolutely awesome. We're coming back. So I'd like to thank the speakers. I think the talks were universally good tonight. And I can tell you that I traveled here from Berkeley, California, so I probably traveled the furthest of anybody in the auditorium tonight, and it was well worth it. It was a wonderful set of talks and just delightful to be here. So if you have questions about us at Altinity, we're going to hang around. Be glad to take them if you're looking at diving into ClickHouse. I think there's been abundant evidence that it's a great database. I mean, there's people here that want to marry it. So, talk to your spouse first. So with that, again, thanks again. It's just wonderful, and we'll be hanging around as are the speakers. So talk to you soon. Bye.